Welcome back. This is Sachin again, and today we'll be talking about an important networking component called transit gateways. Transit gateways are there to basically connect multiple VPCs together to stabilize the communication. It's highly available. It can connect hundreds and thousands of VPCs, not only within a region but across region, and basically the traffic flows between regions or cross regions via these transit gateways are secured and encrypted. So this is like more secure, and this is preferred by AWS. I think somewhere it was launched somewhere in 2019. And before that, to connect multiple VPCs, VPC peering was another approach, but transit gateways are preferred because the number of connections needed for to connect multiple VPCs, they are like growing too much in case of VPC pairing. However, in case of transit gateways, all you need to do is like each VPC just do a connection with the transit gateways, and they all can talk with each other. And you can have a fine grained control and all that. By the way, on the basics for transit gateways and a demo, I have already created my previous videos. I highly encourage to you go there and watch it. In my channel, you find this AWS transit gateways demo, and you can have a look on this. So, but in this video, I'm gonna cover something more advanced. So previously, I have covered like how multiple VPCs can communicate, which are like within a region. However, I want to extend that knowledge and want to showcase and demonstrate the the importance of transit gateways, how you can even do cross communication across VPs which are even in a different region. So for that, we can just focus on this. Like I'm again using my brainboard. I have already created a small tutorial how to use brainboard. This tool I find very useful. You can drag and drop and just you know just configure your components, and then it will create that infrastructure into cloud. Anyways, so the use case here is I'm gonna take three VPCs. Two will be in Singapore region, so primarily VPC1 and VPC2 with their CIDR range 12.0.0/16 and 12.1.0.0/16. They are in Singapore. Both starts with 12.0 and 12.1 respectively. And here another VPC which will be in a US East region, and that CIDR range is 10.0.0.0/16. Anyways, so so we focus here. It's a typical, so all three VPCs are more or less exactly the same. So let's focus on one of the VPCs. So I just take VPC1. You get a public subnet, a private subnet. I have attached an internet gateway, and which via route table RTIGW, route table for internet gateway. VPC1 with the association, it is connected with this subnet. That's why this becomes a public subnet name, subpub VPC1. And there's a private subnet. Both of them have one EC2 instance, and the private subnet via route table, which I named as route RT-NAT, stands for route table NAT, VPC1. And then this is connected with a NAT gateway, and NAT gateway is in a public subnet. One of the mistakes which people do is like putting this NAT gateway in private subnet, and that's why they don't have an internet connectivity in the private subnet. So just be mindful for that. Anyways, so this is one VPC. Similarly, we have another VPC. I'm calling them VPC1, VPC2. Now the use case is to basically stabilizing a connectivity between two VPCs. And what we are going to do is using a transit gateway. You could use a VPC peering, but this demo is specific for a transit gateway, which is a preferred approach. All right, so you can create a transit gateway. It's a regional device, which means in one region you can place one transit gateways, and hundreds and thousands of VPCs you can actually connect with that. If I'm not wrong, I think the limit for connectivity for VPC is like 5,000, but I need to check that. Just have a look for that. Anyways, so once this transit gateway is placed, all you need to do is create these attachments. The attachments is basically to connect your VPC with your transit gateways, and that's what I placed two attachments, one for to connect VPC1 with this transit gateway, and the another attachment to attach another VPC with the same transit gateway. So as I said, attachments are like different types. They they could be used to connect this transit gateway with either VPC or VPN or a direct connect. Or basically, if you have to talk to cross regions, there is another special kind of connectivity called peering. We will see all that in AWS console in a moment, but the whole idea is that this attachment, which is associated with this transit gateway and this VPC with VPC ID and this private subnet. So this kind of this private subnet connectivity has with this transit gateway. Similarly, this private subnet for VPC2 also via this transit gateway attachment is associated with this one. Now this basically completes this loop, but the only thing remaining is that for this subnet to talk to any machine in different VPC, there should be an entry into route table. Basically, if this guy, this EC2 instance in VPC1, which CIDR is 12.0.0.0/16, wants to talk to EC2 instance in a different VPC 12.1.0.0/16, the route table needs to be adjacent, have an entry that to reach this particular CIDR, you have to use transit gateway. So I just want to showcase that configuration. So you go to settings here and go to advanced, and here you can say that for all other connectivity like 0.0.0.0/0, you have to go to the NAT gateway, and that's where for this CIDR range, for this CIDR range, the NAT gateway entry is made. This NAT gateway is basically placed here. However, to reach to this VPC2 12.1.0.0/16, you need to go via transit gateway 12.1.0.0/16. It has to go via a transit gateway, and that's what you see is ttwsc.id, which is nothing but this particular transit gateway. So this is one entry I showed you for this route table. Similarly, this route table also has to know, like, if this EC2 instance in VPC2 wants to reach out to EC2 instance VPC1, the route table should dictate that what should be the mode or what should be the medium via the traffic should flow. Anyways, so don't worry about if you can't make out everything in Brainboard. Once we deploy this component, we will be showing the same thing into a AWS console as well. But just because you configure everything over here and deploy, so I don't have to make any manual changes, and the whole infra will be created into my AWS. So right now I see I'm in the Singapore region. So basically this particular, so I'm expecting 4 subnets and 4 EC2 instance and 2 VPCs. Right now, if I go to my VPC, okay, there's only one, which is a default one. So there is no other VPC other than the default one. So this is my Singapore, and another one is US East. So let me click on North Virginia, which is US East 1. And here also I have just the default VPC. And I just go to EC2 instance, so there won't be anything right now. This is 0 instance running over here, and let me quickly switch to Singapore. Let me get it get loaded. Okay, no instance in North Virginia, so go to Singapore. Perfect. So this is like totally empty. All I'm gonna do here is go to deploy an action, and I'm gonna just apply. Yeah. All right. Okay, so this is the message from the previous thing where I had created and destroyed it, and now gonna recreate everything for this demo. So this will take a couple of minutes. I think 3 to 5 minutes it will at least easily take. So what I'm gonna do here is to pause this video and resume it once everything is up and running. All right, so I see it took like a couple of minutes, 3 to 4 minutes, and finally all the components are already deployed. So I'm still into Singapore region and to my EC2 views for all the running. Let me refresh it. Perfect. So now I see there are 4 EC2 instances getting created. Let me sort it out. And there is like 2 for VPC1. Basically, let me go to the design mode. 2 for VPC1 and 2 for VPC2. Each one have public and private. So basically, they corresponds to these 2 VPCs and these 4. Okay, it gives sometimes unable to connect. That should be fine. It should go in a couple of seconds. Okay, so they basically corresponds to these 2 VPCs, and these are the 4 EC2 instances. All right, and remember we talked about like transit gateway attachment, and this attachment is for transit gateway, and connectivity type is VPC. And also we talked about this route tables where specific routes have been added, which basically for to go to the traffic to another VPC. Like if we talk about for this subnet perspective and this route table, so to go to the traffic to 12.100/16, it should go via transit gateway. So that configuration I've already shown you in the brain board, but let's see how it looks into my EC2 instance. So because I want to check this particular route table, which is in my VPC1 and the private EC2 instance subnet. So let's trace it from there. So I have VPC1, public and private. So I'm gonna go to the private one. So choose the first one, which belongs to this guy, and go down. It should tell the subnet name somewhere. Come down. All right, and this is my subnet. And subnet name I have also given a little intuitive. Subnet private for VPC1. Click on that. Go to the route table, and route table is RT, stand for route table, and this is NAT gateway for VPC1. Click on that and go to the route, and here you see that for all the connectivity it should go to the NAT, and for going to the another VPC, basically for 12.1, it should use transit gateway, and for anything local which is 12.0, it should go to the local one. Similarly, what is for VPC1, let's quickly see the route table for VPC2 as well. And let me go here for NAT gateway for route table. So this is a route table for VPC2. Directly we can check that with the naming convention, and all traffic go to the NAT gateway, but this NAT gateway is basically this particular one, and 12.1 is local in this case because like now we are into this VPC, but to go for the traffic to go to 12.0, it should go via the transit gateway, and 12.1 12.0, it should go to the transit gateway. So all looks good. Now all we need to do is basically check the connectivity, that whether I'm able to SSH or ping the box into another VPC from this VPC. So let's go to my item, and in fact let's go to first EC2 public instance. So I'm in VPC1, a public instance, basically this guy. From here I'll SSH into this one, SSH. So I'm into this box 12.0.0.80, right? 12.0.0.80, so it matches the private IP. Let's SSH to the another EC2 instance in a private subnet, basically 12.0.1.9. So now I'm into 12.0.1.9, which is this particular EC2 instance. Now let's do the same thing for another EC2. So I'm in a VPC2 public. I take this IP address, go to that particular machine. So I'm into this particular machine, the first one. Okay, and now I should go to the private one. Take the private IP, SSH, this guy. Perfect. So now on the one side, I'm in a VPC1 private instance. Basically, just to reiterate, come on, let me enlarge it a bit. So I'm into this box on my left terminal, VPC1 private instance, VPC1 private instance 12.0.1.9, and you can see this is matches CIDR, and the right side is 12.1. So I'm on the right side is this particular box here in a private instance. Now all I'm gonna do here is from this box, I will be accessing this box, and the traffic should ideally flow from the transit gateway. That should enable that. So let's check it out. SSH, and now I'm gonna SSH to this particular box. Let me replace all the dash with this guy, enter. Yes, and now we can see that successfully from one VPC privately we are able to go to another VPC. Now let's try the same thing on the right side. So now here SSH 12.0.1.9, and perfectly we can go from each other. So basically we have stabilized the successful communication from one VPC to another VPC within the private subnets. Perfect. So that shows that, in this demo I'm showing like two VPCs, but in theory you can connect with hundreds and thousands of VPCs within a region with just one transit gateway. It is a highly scalable component, so that can be added. Now let's also see how you can stabilize the connectivity from any of the VPC from one region to any of the VPC to another region. So now for that I'm going to focus on my just let me just bit. So now I already have a VPC in US East 1 region with the CIDR range 10.0.0.0/16, and all the setup is exactly same except that I'm calling it a VPC 0, and all the component you can see is like have suffix as VPC 0, like RT, IGW, VPC 0, and so on and so forth. Perfect. So now this also has the attachments, the same one. Its attachment is of type VPC. Basically, I think I haven't shown it, so let me quickly show it to you. You go to VPC. Okay, I'm already there. And the last you'll see transit gateways. So I'm in the Singapore region, so I'm going to show you the right part. Okay, so let's go to transit gateway, and this is the transit gateway TGW SG, which I have created. You see the name TGW SG. Click on this, and so once for this transit gateway, just remember the name, it ends with ABB. If you go to transit gateway attachments, let me check all the available one, which is the one which I'm currently using. All right, so these two you see for the VPC connectivity. Because why two connection? Because with this transit gateway there are two, VPC 1 and VPC 2 are associated, and that's why you see two entries over here. All right, and the resource type is VPC. So basically the attachment which we have created, in fact let me quickly show it to you. If you go to create transit, I'm not going to create it because everything is already there, but just to show you, when you create an attachment, the attachment type, if you have connect to VPC, like here in my case, you can give the attachment type as VPC. However, there are other options. If you connect to VPN, or direct connect, another special type of peering which has been recently enabled. This is for cross region. So that's what we are going to use to communicate between two transit gateways into two different regions. And let's see how we will do that. So now here, to stabilize the connectivity, the peering type, you need to create a special kind of an attachment which is of type peering. And for that, in Brainboard, I have created this particular component. Let me quickly go to settings and show it to you. The setting type is AWS EC2 Transit Gateway Peering Attachment. So basically you have to create an attachment. You have to provide three information over here. The two is basically both the region transit gateways, and one is the region name. So basically, because I'm creating a attachment into Singapore region, I need to give the other region as US East 1, and the other transit, the peering transit gateway, this particular one, TGW US East 1, and the transit gateway is for TGW SG. So that three configuration you can see over here. The peer region, from this perspective, the peer is US East. The peer transit gateway ID is TGW US East 1, TGW US East 1, and the transit gateway, basically this particular transit in this Singapore region, is TGW SG over here. So let me cross it. So this attachment is created, but this attachment by default will not get activated until unless the other person should accept it, and that's where you create another component. I'm gonna go to settings, show it to you, is AWS EC2 Transit Gateway Peering Attachment Accept. So this is basically accepting that connection, and all you need to give is basically the reference or ID for TGW peer attach, and that's what I've got done here, TGW peer attach.id. Perfect. So once, because when I deployed my component, this was already there, And that's why you see, okay, let me close it, go to Singapore and VPC, transit gateway attachment. Perfect, let me state. All right, so these two you already see, and one attachment which ends with 076, if you could remember that. This basically, this attachment 076 shows this peering connection, so that's why it should be same for both the region, the Singapore or US East 1. And this type is peering. So all it says that this is a transit gateway ABBB, which is transit gateway in this particular region, this guy, and it's a peering, and the resource is 48E. So in North Virginia, you will see the same record, but 48E will be in the main on the gateway side, and the resource will be ABB. So let's quickly verify that. Go to North Virginia. And here you see the peering, which is the active one, 48E. So basically they have switched because from its perspective, this is the transit gateway and this is the one. And because we have also given the accept over here, and that's why when we deployed, this has automatically accepted, and that's why you see available over here. Correct. Now, which means that this connectivity is already stabilized. So which means ideally, when I'm into this particular box, I should be able to connect to any of these machines, which is in a private subnet. And remember why I'm talking always about private subnet. Public I have placed in all three regions, just they act as a jump post, which whole job is to person can access into this box and securely go to the private one, because only private subnet is associated with transit gateway attachment, and so all communication will be done via all the private subnets only, because they are associated. Attachment is only associated with this guy. You can actually associate more than one subnet, but in this demo I'm not worrying about my public subnets. I'm just trying to stabilize the connectivity all the private subnets. Anyways, so the final piece is to basically SSH from this box to a machine into North Virginia. So let me go to EC2 in North Virginia and grab the IP address for private machine. Okay, let me open North Virginia over here. SSH. Two instances running, one for public and one for private. So let's go to public instance. Okay. Okay, let me fix the permissions for this particular file so it doesn't complain while we SSH. Anyway, so I'm into public instance for North Virginia. That's why you see the CIDR starts with 10.0.0.0/16 range. And let me also go to the private instance. Okay, yes, and 2400/. Okay. All right, so this particular machine, I'm here in North Virginia, and 12.0 I'm into Singapore 12.0, this particular machine, and I'm trying to SSH from this machine to this machine. So now if I say SSH 10.0.1.246, and that's it, it's not working. The reason being that though we have created a peering connectivity attached and associated, and that's how you could see when we go into a VPC, the peering connectivity and all the available over here. Transit gateway attachments, everything is green over here. Everything is green. Peering connectivity is there, it is available, but still connectivity is not there. The reason being that though they are connected, but still somewhere we need to provide a routing that if you are going into this particular CIDR range, then you should be using this transit gateway. Okay, let me refresh it. All right, And that somehow I still need to figure it out how to do it in Brainboard, but I want to show it also that how you can manually do that. So the only one part manual I'm going to do that, and this will be like more clear what exactly I'm going to do to stabilize the connectivity between these two VPCs, which are into two different regions. All right, perfect. So let me enlarge it a bit over here. Okay, come down, perfect. All right, so all I'm gonna do here is I'm into a North Virginia region. I'll go to Transit Gateway Route Tables. In fact, I should go to Transit Gateway Attachments. I should get a hold of this peering connection. I'm catching this guy, peering connectivity. And there is an associated route table. So internally it uses route table, and we need to basically enable the connectivity from here. So now you see routes, it's loading route, and you see there's already one route because we have attached this particular VPC, and that's why you see this is automatically created. We haven't made an entry, but this is route type is propagated. But because now I know from here I have to create connectivity to these two different VPCs, I'm going to create a static routing. So let's do that. So from here I want to reach both the Singapore VPCs. So 12.0.0.0/16, I should be using this peering connection, create a static route. So which means from here I can go on the first VPC. Now again I'm gonna attachment, get this peering route table, routes, and so now you see this is static. One has already been created and active. Let's create quickly one more because I have to SSH to VPC2 also. 12.1.0.0/16, and again SSH to that connection. So this has been done from the North Virginia perspective. So now it makes both the entries. Okay, peering connection, table, routes, and we see one which was already propagated for this part, and manually I have made an entry that if you have to reach to 12.0 or 12.1, you should be using this particular transit gateway peering connection. So this is like from North Virginia to South APC, like Singapore region, but we also have to do the same thing from the other side. So I'm going to Singapore region and go to transit gateway attachment. Again, catch the peering connection, go to the route table, routes. Okay, and this has two routes here, and they both are propagated, which means they are like automatically created. Why they have there are two records already here? Because you have attached two transit gateway attachments, and that's where it has already populated these two. But from either one of these to reach to 10.0.0.0/16 CIDR range, we need to create a static routing for that. So let's quickly do that. Okay, static routing. We need to reach 10.0.0.0/16, and we need to use this transit gateway peering attach connection, create static route. All right, so we see that like even if we want to SSH from the private instance from Singapore region to North Virginia, it's not working. Even we have added the static routes in these route tables, transit gateway route tables. If you go here and the routes, even we added these for peering connection, the static ones, it's not working. It's the reason being that for this guy to reach the traffic here, the route table also must be aware that the traffic should flow via this transit gateway, and that's the only last missing piece. So let's quickly get added for both US East region and Singapore region. So let's quickly do that. So right now I'm in North Virginia region. Let me go to VPC and route tables. I need to get hold of this particular route table, and this particular route table is for NAT gateway. So basically this is the one, and yeah, let's edit route. So add route for first VPC /16. It should use transit gateway, and then also add one more entry, 1.0.0/16. You should again use the same transit gateway. Perfect. So this is one entry. I mean two entries for US East 1, because this guy has to either go here or here. The route table must be aware. So for both of these two cases, you should be using this particular transit gateway, and similarly one for each VPCs over here. So let's go to Singapore region. Okay, route tables, and I know by my naming convention that for VPC1 NAT gateway, this is the route table, and I go to edit route, add one entry that to reach 10.0.0.0/16, which is a CIDR for US East 1. I should be using transit gateway for this guy basically. Okay, so one entry for route table, this route table, another entry for this particular route table. So route table and VPC2, VPC2 IGW, yeah, this one. Edit routes, and the same entry, 10.0.0.0/16 transit gateway. Save changes. Right. Perfect. So now this entry has been made. So let's finally again try to, so right now I'm in 12. Okay, so the same thing. So 12.0.1.9. So 12.0 is this VPC. So we are here, and I want to go to this particular box, which is 10.0 range. So SSH 10.0.1.246, which is an IP address for this particular machine. Perfect. Now we see that we are able to SSH from VPC 1 to VPC 0, basically from Singapore region to the US East region. So let's quickly check that from this machine whether we are able to go to this machine, or let's try to VPC2, so that also will be tested. SSH. Now from here we are in this machine. I want to go to 12.1 CIDR range. So 12.1, let's quickly see the IP address for Singapore VPC2. So VPC2 private is VPC2 private is 12.1.1.27. 1.1.27. So basically from US East 1 to Singapore VPC 2. Yes. Perfect. So we have seen like how powerful this transit gateways are, and not only you can enable the connectivity within a region for VPCs, but across region also you can stabilize this connectivity. So I find it like very powerful and convenient to use it. It makes the architecture very clean. If you like this video, please give some likes to this so I can make the same content in future as well. Thanks for watching.